Hey everybody, it's Dr. Morgan again, coming to you from my office in McNear Hall at RBC, room 123. If you are taking classes on campus this semester and want to drop by and talk to me in person, that's where to find me, McNear 123. I'm here all day long. I only teach one other in-person class, so you can usually find me here. I wanted to take some time now on the first day of the class, or even before the class. I'm going to post this. Today is Friday, the 26th, so I'm going to post this afternoon. If you are getting Canvas notifications to watch videos, you might be watching this before the class officially starts on Monday. But I wanted to go over the syllabus and the course policies and the grading and stuff like that, important first day stuff. I'm going to try to keep it brief because the syllabus is always there. You can always read the syllabus whenever you want. I'm going to share my screen now and show you the Canvas landing page for the course. When you log on to Canvas, you should see this splash page, and this splash page has a few important links. A link to the syllabus, which we'll look at in just a minute. A link to the course announcements, which you should get in your email when I send out an announcement, which I'll do probably about once a week at least. But if you lose track of an announcement, you can always come to Canvas. If you lose track of the email, you can always come to Canvas and find that announcement. The assignment list, which shows what assignments are due, and the pages. And the pages are down here. I'm going to, some of you who have had professors use Canvas a lot for the course, they use modules. I don't really like the way modules are structured on my end. I much prefer to use pages. So I'm setting up the course with, for now, 4 pages, one for each sort of unit that we cover in the course. An introduction, overview of astronomy. Around the middle of September, we'll start talking about the solar system. In October, we'll be talking about stars and stellar evolution. And then at the end of the course, we'll be talking about galaxies and cosmology. If you click on one of these pages, the only one that's open right now is the overview. Oh, that's... the link doesn't work right now. Hold on a second. If you click on the pages, it looks a little different on, I should have switched to student view. It looks a little different on my end from your, but if you click on the pages, you will see something like this. A list of dates and a list of stuff to do. I think I said in the pre-introductory video that I'm going to put up content for every single day. About a half hour to 40 minutes worth of content every single day. You don't need to watch the videos every single day. I would recommend at least every other day and never going more than 3 days without catching up with the course material. But this is just an easy way for me to organize the material and the links to you. So some of them are links to YouTube videos. Some of them are links to the textbook, which is a free online textbook we'll talk about in a minute. And some are links to videos from other people on the internet, explaining things about astronomy better than I can, with better visuals and better graphics than I can. So why should I do all the work when there are other people out there who can teach you some of these very specialized topics better than I can? So the course content will be a combination of my recorded lecture videos, other people's recorded YouTube videos, readings from the textbook, and the occasional article and news piece that I might want you to read if there are important current events that happen during the course. So every few days, check this list. You'll usually be able to go a couple of days ahead. I'm not going to have the whole course up here now for you to peruse. So I wouldn't try to get too far ahead, but I wouldn't fall too far behind. The other thing you will have links to, here's a link to a lab. The first lab we're going to do in the course is there will be links to labs and assignments that on the day that I assign them. So everything you do in the course you will find in these pages. I'll fix the links and make sure it looks the same on your end as it does on this end. So right now only Unit 1 is open. The thing you should do on Monday is to check what stuff you should be doing on Monday in Unit 1, watch the videos, read the readings, and so on. Let me click on the syllabus link. The course syllabus is available in the Files section as a Word doc, but it's also available right here in Canvas. All your Richard Bland College syllabi should look the same. They start with the contact information of your professor. That's me. The phone number. That my office. Don't bother calling my office phone. I never check them. I've got 23 unread messages on my office phone. I don't listen to voicemail really. Send me an email, and you'll get a very quick response. I usually am checking email all the way up until about 12:30 or 1 a.m. And I usually start checking email about 8 in the morning. So anytime in that window you send me an email, you usually get a pretty quick response. I usually respond to student emails almost immediately. The weekends, maybe you'll have to wait a couple of hours, but I'm usually never far from my email. Course description. This course is about the whole universe, which is a lot of stuff to cover. Astronomy and cosmology, those terms mean something slightly different. Usually when we're talking about astronomy, we're talking about the stuff in the universe, stars and planets and galaxies. When we use the word cosmology, we're talking about the universe as a whole. So things like the Big Bang Theory. There are different ways to structure an astronomy course. The summer course that I just finished, I actually structured different than usual. I didn't love it. But because the summer class was so fast, I couldn't do the regular structure. It didn't make any sense. The most common structure for an astronomy course is usually called inside out. You start with the Earth and Moon, then you learn about the solar system, then you learn about the sun, then you learn about stars, and you learn about galaxies, and then you learn about the universe as a whole. So you start small, and you get bigger and bigger and bigger and work your way outward into the universe. That's pretty much the way this course is going to be structured. There are other ways to do it too. You can do it historically. You can start with the moment of the Big Bang and then study galaxy formation and dark matter and star formation and planetary system formation and then planets at the end. That one doesn't make as much sense to me because you have to know an awful lot about physics and astronomy to understand how we know about the Big Bang. Although the thing that is good about that structure is that you learn about the really cool stuff early. Stuff like the Big Bang and black holes and why we think the universe is 13 point whatever billion years old. So it has some advantages for the student, but it's hard to conceptually structure a course that way. So we're going to start with some just general stuff about astronomy, general stuff about the sky, some vocabulary, understanding what light years are and astronomical units, understanding how we're able to know things about objects that are billions of miles, billions of light years away. One of the things that makes astronomy interesting as a science is that we do not get to directly interact with the thing we are studying. For the most part, all we can do to things in space is look at them. There are a few exceptions to that, but most of the information we have about planets and stars and galaxies comes from looking at them with telescopes. Sometimes telescopes that we can look through with our eyes, sometimes more complicated telescopes that see other wavelengths of light, but we're still just looking at them. And so one of the things we'll spend a lot of time early in the class talking about is what are the tools available to physicists and astronomers to know things about very, very distant objects just by looking at them. So we'll have to learn a little bit of physics in the beginning of the course in order to understand how astronomers know anything at all. And I mentioned this in my preview video, that sort of welcome video, that astronomy is a very fast-changing field. We just launched a major new space telescope, the James Webb Space Telescope, into orbit. That is going to provide us with a ridiculous amount of information over the next 10, 15 years. The stuff in your astronomy textbook that was published, a new edition was published last year, will all be obsolete in 10 or 15 years. That is one reason why I don't make you spend $150 on a textbook. We will be using a free textbook from a company called OpenStax. OpenStax has free textbooks in all sorts of different areas, from biology and chemistry and physics to astronomy to psychology. It has math textbooks that are all free. So I'm gonna quickly, you can read the course objectives and the learning outcomes. I'm not going to go through those one at a time. If you go to openstax.org, you will find the astronomy textbook there. I will put a link in the announcements that I send out in the first week. I'll also put a link on the landing page, on the home page, to the course. The main source of information about this course will be my lecture videos. The OpenStax Astronomy textbook is there for you as a supplement to read after my lectures to get some more in-depth information about what the lecture is about. So you can view those as two things that complement one another, the lecture videos and the readings. You should do the readings, but the textbook is free, so it won't cost you anything out of pocket, and you don't have to worry about it being obsolete in 15 years. Like all of the astronomy textbooks on my shelf behind me are obsolete, at least all the ones that I had when I was in school. Lecture videos I already explained. I will have content posted every day, somewhere around a half hour a day, an hour every other day. As far as how to consume the lectures, I would recommend that you not watch them the way you might watch just a random YouTube video on your own time. I would recommend that you treat lectures in this course and all your online courses the same way you would treat a lecture in an in-seat course, which means the only window you have open on your computer is the video. You have got a notebook and a pen in your hand to take notes about all the things in the video as if you were sitting in a lecture class. It's not an option to just go back and rewatch all the videos again when it's time to study for the final exam. You should have notes to study from. One of the things that I always say I'm going to do, I never get around to because it's going to take a bunch of time for me. It's for me to watch one of my own videos and pretend to be a student and take notes on that video and then post that to Canvas and say, this is what you should have at the end of watching a 30-minute video. These are the kind of notes that you should have in order to help to burn those ideas into your brain. So watching the videos actively, jotting down notes, jotting down questions, things you don't understand, posting those questions in the comments to the YouTube video. All of my videos are going to be on YouTube. If you have a question and something you don't understand and want to ask a question about it, you can just ask that question in the comment section on YouTube, and I will get an email notification about that, and I can answer that either in the next video or in a separate video or in a message to the course. So engage as actively as possible with the videos and with the readings, taking notes, writing down questions, etc. This is a 4-credit lab course, which means there are labs. Obviously, we're not in person, so we can't go into a physical science lab and do experiments. Obviously, you don't all have a telescope, so you can't do astronomical investigations on your own. So our labs will be mostly simulations, data analysis, and kind of pen and paper activities simulating astronomical observations. There'll be a lab assigned every Friday. That lab will be due the following Friday. The only exception is weeks when we have big exams like the midterm. So you should get a notification in your Canvas assignments when a new assignment is posted and when a new due date is posted, and you'll always have a week to work on every lab. The labs are, I think, fun and easy. They're not super complicated. Some of them are a little tedious and time-consuming. Some of the data-driven ones where you have to make graphs and stuff, but they're not mathematically complicated. You don't have to write a lab report. You just do the activity and answer some questions. So the labs are an important part of your grade, but shouldn't be particularly a difficult part of the course. There are also going to be exams, a midterm and a final. The final exam isn't cumulative, so the midterm covers the first half of the course. The final covers the second half of the course. Those together are worth about 50% of your grade. The labs are worth about 20% of your grade. The rest of the bulk of your grade is made up of written assignments. There is a midterm paper called the NASA Mission Priority Assignment. I will probably be telling you about that in late September. And you can get started on that and have the whole rest of the semester to work on it. And I will be posting Canvas quizzes every week or so. Don't think of these as quizzes. They're called quizzes because Canvas calls any little assignment where you answer questions in Canvas is called a Canvas quiz. Think of these as homework questions. Some of them will be quizzes where you're expected to answer this question without consulting the internet or consulting your notes, just answer it on your own. Some of them will be, here's a little research project. Go out and tell me something about the new JWST. When was it launched? Why was it built? What wavelengths of light does it see? What questions was it built to answer? So just a little 150-word writing assignment. Some of the questions will be critical thinking type questions, asking you to make connections between two things we saw in two different videos, or to give your opinion about something. So those will be, again, roughly every week, and are collectively worth 20% of your grade. And then Canvas participation. I will, every couple of weeks, log on to Canvas, go to the participation statistics page. I can see how much time you have all spent logged into Canvas doing things. And if you have not spent more than an hour or so in the past 2 weeks in Canvas, I know that you're not really engaging with the course. So there will be an attendance grade in Canvas where I will mark a lower number when I check that Canvas attendance. So again, you don't want to be away from the course for more than 3 days. I would say every other day is a minimum. So I will be checking that. Your lowest 2 lab grades will be dropped from your average. That helps everybody else. If you miss a lab for some reason, that helps you out and helps your average just a little bit. And the grades are calculated according to the usual 90s or A's, 80s or B's, and so on. I do curve grades on exams. The way I determine grades on the midterm and final is I list everybody's grade in descending order. I look at them and figure out where a reasonable cutoff is between A and B, B and C, C and D, based on where the kind of gaps are in people's score. It's not a very scientific methodology, but I do come up with sort of a formula in Excel to determine where the cutoffs are. In general, what this means is that whatever your raw grade is before any curve on a midterm or a final, you usually get between 5 and 10% added to that score. So it's everybody's score goes up, nobody's score goes down. And the reason for doing that is just to make the grading as fair as possible. Grading is subjective. Any teacher that tells you the grading is not subjective is lying to you. And so making that curve, setting those cutoffs based on group performance is a way to kind of even out the grades and make things more fair. I will say that in this online course, I give a lot of C's, and most people who get C's are people who stop engaging with the course 2/3 of the way through, stop doing labs, stop doing the assignments. If you do all the assignments in the course, if you watch all the videos, if you take notes, if you understand the material, it should not be difficult to get a B or better in this course. Students who get less than a C are students who completely disengage in the course and just stop doing the work. So don't do that. Late work policy, I will take late homework and lab reports. I will mark them down by 1 letter grade. And you can't get a grade higher than 80% if you turn in your assignment late. Quizzes, same thing. They will have due dates. If you do them late, I'll reduce your grade by 1 letter grade. Exams you cannot do late. If you have some kind of emergency and you know ahead of time you're going to have to miss the midterm exam or the final exam, please let me know ahead of time, and we can make arrangements for a separate version of that exam. If some actual emergency happens that involves someone being in the hospital or someone, being absolutely unable to engage with the course, let me know and we can make special arrangements for that. But those are actual real big-time emergencies that we make those exceptions. The course attendance policy is different for an online course than an in-person course. Again, when we say that the course is self-paced or asynchronous, it means that you don't have to be watching videos on Canvas at some particular time every day. It does not mean that you can just wait till the last 3 weeks of classes and watch all the videos and do all the assignments and take all the quizzes. That's not how it works. There will be assignments due every week. There will be content that you're expected to engage with every week. There will be labs due every week. So you are expected to be logged into Canvas every couple of days to see what's going on and to participate in the course, and your attendance will be marked down accordingly. If you do not, the COVID-19 addendum doesn't apply as much to an online course. Obviously, you don't have to worry about quarantining if you're exposed to COVID. If you're actually sick with COVID, too sick to work, then let me know, and that would be considered a sort of excused medical absence, although I think I had COVID last semester. I still taught my online classes. My kids had COVID, and they both still attended their online classes. A mild case of COVID is no worse than a cold. But if you're very sick, obviously, that's different. There's a list on all of your syllabi you get from all your RBC professors about student support services, advising, counseling, etc. Please be aware of all of these links. You'll see them in every single one of your syllabi, and take advantage of them if you need them. If you have course-specific issues, contact me, email me, swing by my office, swing by my lab, and we can talk about course-specific issues one-on-one. And that's it. Mission statement. Academic integrity. This is super important for online classes. I'm not going to use honor lock. I'm not going to use Turnitin. I'm not going to use any high-tech anti-cheating mechanisms. But I am really good at spotting sentences that were not written by first and second year college students. I've been doing this for 25 years or so, and almost every year I catch some student who has copied some stuff off the web and pasted it into a paper, or pasted it into an exam, or has posted the questions from my exam to chegg.com and gotten somebody else to answer it for $10 and then pasted it into my final. I have an account on Chegg, I have an account on study.com, I have RBC has an account on Turnitin. The temptation to cheat should be avoided. The temptation to test my ability to figure out if you cheated should be avoided. I take honor code violations very seriously. I had to fail 3 students in 2020 for cheating on my final exam using Chegg.com, and it's not worth it. This is not a difficult course. This is not a course where you're going to be asked questions that you shouldn't be able to answer if you've been watching the videos and paying attention. So, don't do it, because I will probably find out. That being said, if you have a roommate who's taking the class and you worked on a lab together, just say that. You know, me and Claire worked on this lab together, and that's fine. When scientists publish a paper, they don't publish it all by themselves. They have collaborators. But they don't just put their own name on the paper. They put the name of their collaborators, and it's understood that this work might have had input from someone else. Now, that being said, you should always hand in what is your own work. You shouldn't copy an assignment and give it to someone else. I will not accept 2 assignments that are identical to one another, even if you say, oh, we worked together. Control-C, Control-V is not working together, right? That's just copying. But if you work together so your numbers are the same or some of your ideas are the same, that's fine. Just cite that the way you would cite it if you were writing a paper. And if you are writing your midterm paper and there's a great big quote that you really, really love and you want to put it in your paper, the solution to that is to put quotation marks around it and to put the citation and to paste it into your paper. That is how you cite sources in academia. So I don't want to belabor the point of academic integrity. Just do your work and don't copy stuff from the internet. It's really, really simple. Important dates. The last day to drop the class is September 2nd. This syllabus has a bunch of dates and kind of when we're going to be covering different topics and what the topics of the different labs are. Don't take these dates too seriously. They'll ebb and flow and shift as maybe some topics take a little more time than others. Some topics take a little bit less. But we start with kind of talking about the general ideas of astronomy in the sky. We'll be talking about the solar system in the middle of September. We'll be talking about stars and stellar evolution in October, galaxies and the Big Bang in November. Our exam week is the week of the 12th. I will be posting our final exam, which will be all online, on that Monday of that last week, Monday, December 12th. Will be the date of your final exam. I may have it open for 2 days. I may have it open Sunday and Monday, and you'll know more about that as we get closer and closer to that date. That is it. So the only other stuff we need to make sure we know about on Canvas is if we click on the assignments page, you'll have all of your course assignments. There's a quiz already up there that you can take right now, which is just asking some general questions about you and what you're interested in, why you're taking astronomy. It's not really a quiz, it's just a questionnaire for me and a way for you to make sure you know how to use the Canvas quizzes. Your labs will all be here. They're not published yet, so you won't see these yet when you log in. Your labs will be here, the midterm and final exam, your Canvas participation. So this is where you will go to see all your assignments. The discussion board, I have never, in all my year, I've been teaching, well, almost since the internet was invented, and I've never been able to make discussion boards a robust, meaningful part of a class. They always kind of just fizzle out, and if I want discussions to get going, I have to post more to the discussion boards than the students do. That being said, I will use the discussion boards in this class as a place to post and tangents, things that are off to the side of the course, things that maybe I don't want to devote a whole video to, and news stuff. If you're watching this on Monday, the first day of class, NASA is launching a moon rocket, a test of our uncrewed Orion capsule. Well, the Orion capsule is going to be crewed. We are doing an uncrewed test without humans on it to test our new moon launch and landing system that hopes to put humans back on the moon by 2025, 6, 7, 8, something like that. So I will post links here about that mission. This is also a place where you can post questions or post interesting stuff you find about astronomy. It's not a requirement. I'm not going to grade your posts. I'm not going to count who posts what. It's just a little bonus extra coffee break discussion section that's parallel to the course. So that's there. You can obviously, if you know how to use Canvas, you know how to click on your grades and see your grades. Oh, and the files section will have lab handouts sometimes. You can find the syllabus here. Study guides. Before the midterm and before the final exam, I will post sample questions to give you some sense of what kinds of questions to expect on the exams. Those will be posted here. Lab handouts, the NASA mission paper assignment is already posted up there. There's some links up here from OpenStax that I'm going to start putting in all my classes. OpenStax has some college readiness, college skills, productivity, time management documents that I have looked over and actually pretty good. So if this is your first semester in college and you want some tips for how to keep yourself organized, how to meet the expectations of college level work, these OpenStax links might be helpful to you. I'll move those links to the homepage as well, so you can see them there. And that's it. Gosh, I've been going almost a half an hour now. That's longer than I had hoped to go, because I do want you to actually watch some astronomy videos today too. If you have any questions about the course policies and grading and stuff, you can ask those in the first quiz, because one of the questions on that first quiz is, do you have any questions about the course and how it will run and what the expectations are? It's pretty straightforward. I think this is a class that works really well online. Astronomy is my favorite thing to teach. Physics is what my degree is in, but teaching physics is it's just a lot of fill in the board full of equations every day. It's not always big ideas and interesting stuff and cool pictures of planets. So I like teaching astronomy a lot. Hopefully you'll be able to tell from the videos that I like teaching astronomy a lot. Yeah, so let's get started. I think I will post one more video that's kind of an introduction to astronomy as a field. And then, yeah, we'll get started with the actual course videos.